So in the last class, we have seen about heuristics. And what do you mean by heuristic? So heuristic search is nothing but informed search. So we have some more information related to the environment other than only the initial state and the goal state. We have some more informations, and there is a difference between heuristic search and non-heuristic search, means uninformed search and informed search. So uninformed search is the search without prior information, but informed search is what we do is here we'll take some information here. So in the uninformed search, we doesn't have knowledge, but in the informed search, we have some more knowledge to step up towards the solution. Uninformed search is time consuming and informed search is quick solution. Why? Because we'll get some more information about the environment. More complexity here. Uninformed search is having more complexity, time and space, but informed search has less time and space complexity. And some examples are like depth first search, breadth first search, uniform cost search, iterative breadth first search. So these type of iterative depth first search, these type of algorithm is there in uninformed search that we have seen in the last few classes. And in the informed search, what we have seen till now is we have seen A star search, best first search. So best first search we have seen along with A star search. And I told you the difference between A star search and uniform cost search, because the uniform cost search is coming under uninformed search, and A star search is coming under informed search, where we have some heuristic value along with the different information. If we'll talk about what do you mean by heuristics, so heuristics are nothing but some additional information that is provided about the environment, and these additional information we can get using the heuristic evaluation function, which actually tells us the cost between any node to the goal node, and that we can find out by different methods. We'll use a straight line distance method, triangle inequality theorem methods, or Manhattan distance. So any of these heuristic value finding algorithm we can use to get some heuristics. After that, we have seen best first search. So what was the difference between the uniform cost search and the best first search is, in the best first search, will expand that node which has the best cost, means in terms of heuristic. In terms of heuristic, which has the best cost. Best cost means the cheapest cost. It is also called cheapest cost first. Okay, this particular search is also called cheapest cost first. Now here we use heuristic evaluation function and will estimate the cost, and that cost is written instead of the actual path cost. So actual path cost information is not there, only these evaluation function value is there, which will be generated by heuristic evaluation function HL. We have seen some of the example. I think 3 example we have seen in the last classes. After that, we move on to greedy best first search, which is a variation of best first search. What was the difference? The difference was here, instead of heuristic evaluation function, we have heuristic values, and that values, as we have discussed, the values we can get by any of the method, like straight line distance, triangle inequality theorem, or Manhattan distance. So here it is using straight line distance to get the information from any city to the goal city. Okay, and based on that we'll take the decision in the greedy best first search. We have seen some examples also related to it. Now come into A star search. This A star search is using two values instead of one value that was there in the best first search that we have seen in the previous one. Here there are HN, means there are heuristic value, but along with that we'll take the path cost, whatever the path cost is till now, and what is the heuristic value from for that particular node will add up and we'll get Fn. Here in A star, that Fn is called A star score, and based on that score we'll choose which node to expand. Whose score is less means this cost will be less, that Fn value will be less. We'll take that particular node to expand to get our goal node. So here, instead of only one value, we have two value, and based on that, we'll choose our next node to expand. So we have seen the example. This is the example for the uniform cost search, where these value are the path cost. And this is the example for A star search, where these value are path cost. Along with that, we have some heuristic values, and these heuristic value tells us that from that particular node to reach any of the goal node, what should be the cost. Okay, so this example we have seen in the last class.